ABC Wednesday.
Y'all complain all day. We want books. We want paper towels in the classroom. Bet you want raises too.
I'm still waiting on the paper towels.
Abbott Elementary returns with the new season.
We asked the district for more after-school programs. They gave us $50 for class pets instead.
Critics cheer. Abbott Elementary continues to be one of the funniest and most beloved shows on TV.
What y'all doing out there?
Taking bribes.
Proud of y'all.
Abbott Elementary. Season premiere Wednesday, 9:30, 8:30 Central on ABC and stream on Hulu.
Hello, and welcome back to 3D Printing Basics. This is episode number 6, which will be all about 3D modeling. We will be diving into what goes into creating a 3D model, the different softwares you can use, and some basic tips and tricks that I have learned throughout the years. But before we get into it, I of course have to ask if you would please follow and rate this podcast. It would really mean a lot to me. The support I have received thus far has been nothing short of amazing. Also, if you have any questions about 3D printing or have a topic you would like me to discuss, feel free to email me at 3dprintingsquared@gmail.com. I will also leave my email in the show notes. With that being said, let's get into 3D modeling. 3D modeling was first invented 60 years ago when a computer scientist named Ivan Sutherland created Sketchpad, the first program that enabled a computer to, quote, read drawings on a screen. This invention led to many acknowledgments and accolades for Ivan, as well as led to him being known as being the godfather of CAD programs. Speaking of CAD software, let's talk a little bit about what that is. Computer-aided design software, known as CAD software for short, arose from the original invention of Sketchpad and has since developed into the software that almost all 3D artists use today. While there are many different companies out there with their own versions of CAD programs, they all accomplish the same task. That task being using the help of computers to aid in the creation, changing, and streamlining of designs. From being an architect designing a brand new house to us 3D printers modeling parts to print, CAD software is used across many different industries and is a vital resource for the world today. In some instances, CAD is a standalone software, and in other instances, it is used in tandem with something else. I will go back to using the example of my day job, being a machinist. In the machining world, we use CAD that is also integrated with something called CAM, or Computer-Aided Manufacturing Software. This allows us to create 3D objects, program the tool paths for how to cut these parts, and then send the G-code instructions to the CNC machines. This demonstrates the versatility of CAD and shows how many different uses this amazing program truly has. However, CAD not only can be integrated with other types of software, there are also different types of CAD software itself, mainly 2D CAD and 3D CAD. 2D CAD is pretty much just for drawing and sketches. It's very simple and often referred to as lower-end CAD systems. 3D CAD is what takes those two-dimensional drawings and extrudes them into the three-dimensional space. This is the version that a lot of 3D printers use. That being said, there is a lot of 3D models that start with a flat 2D drawing that then gets extruded into a 3D object. A lot of the popular programs like Fusion 360 and SolidWorks use this format. So while we are on the topic of formats, let's discuss the general steps on how to use CAD software to model an object for printing. For this example, we are going to be creating a fresh, brand new object. We aren't going to be copying an object that already exists, bringing something from the real world into the computer realm. This object does not exist yet, and we are going to make it. To start, I always create some rudimentary drawings on paper. Usually, these drawings are incredibly rough, but they do contain some basic measurements as well as the general shape that I want the object to take. From here, we hop on the computer. We go into the CAD program of choice and start with a sketch. Usually, I'm just outlining the basic shape, whatever it may be. This is a 2D sketch, and I say sketch like I'm drawing on paper, but that's just the word that is used for the 2D drawing in the computer. So this is a 2D flat sketch, and it's as basic as it gets. From there, I extrude the object, which just means turning it from a 2D to a 3D object and applying thickness to it. From there, I can add on finer parts, say rounding off corners, adding pockets or holes where they need to be, as well as adding text or logos if necessary. Now, an important thing to remember is to constantly be measuring your part. I am always measuring, making sure the logos are centered, holes are lined up, and just overall making sure that everything is concentric and where it needs to be. Because if something gets off kilter and you miss it, it's really annoying to have to go back and make the small change and completely reprint your part. That is pretty much the steps required to 3D model an object from scratch. Of course, the finer or more complex an object you have, the more times you will have to repeat these steps and the more tweaking and finishing work you will have to do. So it is not as easy as it sounds, trust me, I know. Now that we have talked about everything that goes into building a 3D model, I think it's time to dive into some of the specific programs that you can use to model. I have chosen 3 of them, and they range from a beginner level program to an intermediate level program and then an expert level program. These softwares are called Tinkercad, Fusion 360, and SolidWorks. So to start, let's get into Tinkercad. Tinkercad is the most basic, bare bones 3D CAD software out there. This software uses a form of CAD called CSG, or Constructive Solid Geometry. This, by definition, is creating complex models by combining simpler shapes together. So unlike other CAD systems that start with a sketch that you would then extrude into a 3D object, Tinkercad starts with 3D objects. So for example, you would start with a cube or a cylinder and then add or subtract more and more simple shapes until you get to the more complex 3D model that you were looking for. This is a much simpler process and an easier way for beginners to understand what goes into 3D modeling. I have experience with all 3 of these programs, but by far the most time I have spent 3D modeling is on Tinkercad. I found it very easy to understand, especially when I was just getting into it, and it was easy to make more and more complex shapes as I went along. However, Tinkercad does have its limitations. For example, one constant struggle that I had was that I couldn't fillet edges. Every time that I wanted to round over a sharp edge, I either had to export the part and drop it into a different CAD software, or just straight up ignore it and round over the edges myself after the part was printed. And that's something that I really don't like doing, and I would just really like it if they could just add that feature into Tinkercad. I think it would be huge if they could do that. And one thing that I've also noticed while I'm trying to get away from Tinkercad and move more into using Fusion 360 to design is that Tinkercad bears almost no similarities to the more intermediate and advanced CAD softwares out there. I'm finding it extremely difficult for myself to migrate from Tinkercad to Fusion 360, and this is something to consider, especially if you are running a business. Is it worth starting out with Tinkercad if it means spending extra time and resources learning another platform down the road? That's just something to consider. However, even with these downsides, Tinkercad is an excellent software, and it does exactly what it is designed to do, which is provide a great entry point into 3D modeling. With that being said, let's move on into the next CAD software, Fusion 360. I would say that Fusion 360 is right in the middle of the pack in CAD programs in terms of price, accessibility, features, abilities, and ease of use. To start, let's go over the price. For those of us hobbyists, Fusion 360 is actually free because it consists of not just CAD software, but also CAM, PCB, rendering software, also a whole bunch of others. Fusion 360 allows hobbyist designers to use a version that doesn't have all of these features for free. Don't worry though, for us 3D printers, all we really care about is the CAD program, and the free version comes with that. If you're a business, Fusion comes in at around $45 to $70 a month depending on your subscription. Now that may sound expensive, but just wait until we get into SolidWorks. Anyways, Fusion does require a better computer to run as opposed to Tinkercad, because Tinkercad is run on a website and doesn't require anything to be installed. It does not need a great computer to run. Fusion 360 is a standalone program that needs to be installed on a decent computer in order to run properly. Basically, you can't be using this on your grandma's old Dell laptop and expect it to run well, or even run at all. Once you have met the interface requirements, Fusion runs really well. And once you get the hang of it, Fusion is really good for designing new products, ideas, or anything else you might want. On the other hand, that is also a disadvantage. You have to spend time to get the hang of it. In my experience with Fusion 360, I have found that the interface isn't as well designed and optimized for workflow as it could be. Sometimes I can spend up to 10 minutes looking for one feature that I need to make the model work as intended. Now, I'm sure once I get settled in and start getting the hang of it, these problems will go away, but I never had an issue finding anything on Tinkercad, so that is something to consider. Overall, I would say Fusion 360 is the go-to CAD program for many designers, and with good reason. Its ability to offer low-cost, yet high-performance designing software is second to none in its industry. Okay, so now I would like to discuss the final CAD software I've lined up for us today, that being SOLIDWORKS. SOLIDWORKS is easily the number one choice for CAD software amongst professionals around the globe. It is loaded with features and has only recently been integrated with cloud software, which allows access to designs from anywhere. If you are running a big business, SOLIDWORKS is the program for you. Now, I know that sounded like an ad read, I promise it's not, but SOLIDWORKS, if you're listening, I'm open, please sponsor me. I won't spend a lot of time on SOLIDWORKS just because I know that there aren't a lot of business owners listening to my show. SOLIDWORKS doesn't exactly cater to my audience, but here's the basic rundown. SOLIDWORKS is very costly, not something that can be purchased online. The only way that you can buy it is through a verified reseller who you have to contact and request a personalized quote. SOLIDWORKS also has a unique pricing structure. You first have to purchase the SOLIDWORKS license, which gives you the right to use it, and then you also have to purchase a yearly subscription that allows you to receive all the updates that the host company comes out with. Now, the license itself will run you about $4,000, and with the yearly subscription coming in at just under $1,300 for the standard, the most basic version of SOLIDWORKS. This is extremely pricey for most of us, which is why SOLIDWORKS mainly appeals to the professional workspace and not the hobbyists and small-time designers. SOLIDWORKS runs as what's called a parametrics CAD system, meaning that every part that you add in assembly is reliant on the previous part that you are building off of. What this means is, say that you start off with a cube as your base model. If you add a cylinder on top of that cube and then go back and decide to change the dimensions of the cube itself, then the cylinder's parameters will also be affected. This is really helpful for designing whole assemblies such as motorcycles or robots or things like that. And one very helpful feature is it already has CAM software integrated into it, so that you can generate G-code directly from SOLIDWORKS. This is super great for machinists, not 3D printers though. For 3D printing, you will still have to export the model and drop it into a slicing software. But that doesn't mean that SOLIDWORKS isn't trying to appeal to the 3D printing space. They have enabled a new feature that allows users to see what their part looks like on a print bed to make sure it fits, and among other features. I'm hoping that SOLIDWORKS comes out with an integrated slicing software soon, as that would make SOLIDWORKS the primary all-in-one tool for professional 3D printers. Okay, that just about does it for this week's episode on 3D modeling. I hope you were able to learn a lot, including what goes into designing a part, as well as learning what CAD softwares are and which one might be best for you. Don't forget to rate the show, email me if you have anything you want to say, and I appreciate all of the support. Thank you for listening, and I'll talk to you next time.